Friends, today we are going to discuss about acidic nature of the phenols, uh, which is the most important concept from the chapter alcohols and phenols of class 12th grade chemistry. So most of the questions are revolving around this acidic nature of the phenols. Most of the reactions, chemical properties of the phenols. That's why this topic is the most important. You'll get questions in JE and also in the board paper, board chemistry paper. You'll be getting the questions from this concept, acidic nature of the phenols. That's why this chapter is quite important. So to understand the chemical reactions of alcohols and phenols. So first of all, does the phenol exhibit acidic nature? So means absolutely yes, it can exhibit acidic nature. If it exhibit acidic property means, so then how do we know that the phenol has acidic property? Means the simple phenol exhibit the reactions with metals, particularly sodium and particularly with aluminum, and so it reacts with sodium hydroxide, and so by reacting with metals it releases hydrogen gas as the metals react with the acids. So when it reacts with sodium hydroxide, then we'll understand the acidic strength easily. The phenol structure, if you look into the phenol structure, the OH hydroxyl functional group, hydroxyl group is connected to the sp2 carbon, where the sp2 carbon of the benzene ring behave like electron withdrawing group. And so then sp2 carbon maintain double bond with oxygen, where it can result a positive charge on oxygen. So it can result in polarity between oxygen and hydrogen bond in the hydroxyl group due to the electron withdrawing the nature of the so what we say sp2 carbon of the benzene ring. So that means the benzene ring so behave like electron withdrawing group. So then it increase the positive means electron density of the oxygen. So so when the positive charge increases, so on the oxygen atom, it can result to polarity, then losing of the proton takes place, and the formation of phenoxide ion will take place. The formation of phenoxide ion so is a more stable in case of the phenol. Phenoxide ion is a more stable. So how we can explain the stability of the phenoxide ion? The phenoxide ion can be its stability can be explained by the resonance due to delocalization of charge, delocalization of electrons, pi electrons particularly. As a result, it can give 4 resonance structures. So that's why the phenoxide is more stable, and because of its stability, and ionization becomes easy, and due to this ionization the proton will be released, and more is the proton liberation, more is the acidic strength of the acid, we can say. So let us discuss the resonance structures of the phenols. Resonance structure, ionization of the phenol. See, look at this. So phenol undergo ionization. Even alcohol also will undergo ionization. But if you compare with the phenol and alcohol, phenol is more acidic, alcohol is less acidic. So how we can explain this one means the hydroxyl group connected to the sp3 carbon in alcohol, whereas hydroxyl group connected to sp2 carbon in phenol. So sp3 carbon and sp2 carbon, in both cases if we compare, there is electronegative difference. sp2 carbon has more electronegative than the sp3 carbon. sp3 carbon will increase electron density on oxygen, where oxygen will be retaining the proton, so difficulty to lose, whereas the sp2 carbon, since electron withdrawing nature, it can decrease the electron density on oxygen, then so losing of the proton will be taking place. And look at this structure here. So ROH in this, so and when the means ROH alkoxide ion and H plus ion is liberated. And in case of the phenol, phenoxide ion is formed, H plus is released, where R value means so electropositive nature, releasing nature. So whereas this aryl ring, so electron withdrawing nature, so withdrawing electron from the oxygen, and so R in alcohols, R will be releasing electrons into oxygen, then oxygen electron density increases. So, and if you compare with alkoxide ion and phenoxide ion is more stable than the alkoxide ion. Now, so the stability of the phenoxide ion, if we discuss the stability of phenoxide ion, let us discuss the stability of the phenoxide ion. So here the phenoxide ion is more stable because it undergoes electron resonance structures, delocalization of charge and delocalization of electrons within the ring. As a result of this delocalization of the charge and delocalization of that electrons in the ring in the phenoxide ion is more stable, we say, and so the charge density or the delocalization charge will be on ortho position and para position. So, and finally, so the proton liberation taking place. Where in case of alcohols, there's resonance structures are not possible and no resonance. So, and means the phenoxide ion is not undergoing any resonance structures. That's why unstable. Alkoxide ion, not phenox. Alkoxide ion is unstable, whereas phenoxide ion is more stable, we say. So now, if you look at the look into the acidity of substituted phenols, acidity of the substituted phenols. So sometimes on phenol, so on the benzene ring, we could see that substituted structures like methyl, substituted like nitro group. So we see there are two kinds of substituted two kinds of substituents. We say electron withdrawing group and electron releasing group. If the electron releasing group is present on the benzene, electron so releasing group is present on the benzene, it decrease the what we say acidic strength of the phenol. We say if electron withdrawing group is present like NO2, so NO2 electron withdrawing group is present, then it increases acidic strength. Why? What is the reason here? So why the methyl alkyl groups decrease acidic strength means the electron releasing group like methyl, ethyl will increase electron density of the benzene ring. Then and automatically oxygen will get more electronegative nature. Then proton liberation is quite difficult. In case of electron withdrawing group like NO2, what the NO2 will do, it can take away the electron from the ring where oxygen can get more positive charge, more polarity, then easy to liberate the proton. So that's why if you look into the nitro substituted so phenols are more acidic. Now let us see here the orthonitrophenol is more acidic than metanitrophenol, and paranitrophenol is more acidic than orthonitrophenol, and phenol so is a pK value 10, so less than the paranitrophenol, and orthocresol where methyl group is present, less acidic, and metacresol little bit more acidic. Paracresol means methyl substituted, so less acidic strength, we say, and so ethanol means aliphatic alcohol, acidic strength is very low. Its pK value will be 15.9, almost or 16. So for the ethanol, we say. So simply what we tell the reason is that electron releasing group like methoxy group or ethyl group or methyl group connected or substituted to the benzene ring, so decrease the acidic strength we say, and whereas nitro group and the electron withdrawing groups so will increase acidic strength of the phenols because of decreasing of electron density on the oxygen, and the positive charge on the oxygen will help in that ionization process, and releasing proton will take place easily, and acidic strength will increase. Here is the question is given here, arrange the following compounds increasing order of their acidic strength. One is given propanol, and second one is 2,4,6 trinitrophenol, 3-nitrophenol, 3,5 dinitrophenol, phenol, and fourth one is methyl phenol. So in this question, if you observe, what is propanol is given, second one is 2,4,6 trinitroprophenol is nitrophenol is given. So out of all these, which one has more acidic strength? 2,4,6, because nitro group is present on second carbon, fourth and sixth, and electron withdrawing groups 3 are present. Absolutely, it is more acidic. Then afterwards, dinitrophenol, 2 nitro groups are present. The second one, and the third one is nitrophenol, then phenol, then methyl phenol. Last one is propane 1-al aliphatic alcohol is absolutely least one. Okay. So now, so already we discussed this one, and so propane 1-al is the least one, and 2,4,6 trinitrophenol is more acidic because of 3 electron withdrawing groups present on the benzene base. And again, so one more question is possible. If you compare with cyclohexanol and phenol, which is more acidic, means absolutely phenol is more acidic because hydroxyl group is connected to sp2 carbon, so benzene ring, and in case of cyclohexanol, hydroxyl group is connected to sp3 carbon, so and where its conjugate base not stabilized in case of the phenol, conjugate base is highly stabilized. That means in case of the cyclohexanol, the alkoxide ion means what we call conjugate base unstable, and in case of the phenol, phenoxide ion is more highly stable. So more is the stability, so more is the resonance, means resonance structures we say, and that give the more acidic strength of the phenol species. So simple, the acidic property due to the liberation of H plus ion. That liberation of H plus ion come from that polarity of oxygen and hydrogen in the phenol structure. This is facilitated by electron withdrawing group and not facilitated by electron releasing group, say.